All right, here we're going to be learning about symmetry. So there's two types of symmetry that we're going to learn about here. One is reflectional symmetry, where after a reflection, the image looks exactly the same as it did before. Or rotational symmetry, we're going to learn about that on the next page, where after a rotation, the figure looks exactly like it did before. So a figure has reflectional symmetry if the pre-image and the image are the same after a reflection. Each point has a matching point on the other side of the line of reflection. That line of reflection can also be called the axis of symmetry. So you're trying to imagine a line that splits the figure directly in half. This figure got cut off a little bit. So I can imagine two lines of symmetry on this one. One line going straight across horizontally. I could see that if I flip that point, that point, that point, that point over this line of symmetry, they would end up there, having their exact matching points on the opposite side of that line. That's really what it means to have symmetry. It's going to look exactly the same on one side as it does on the other. So we have horizontal symmetry. That's what we call that when we could draw a horizontal line that cuts through the figure. This also has vertical symmetry. When you could draw a straight up and down line, we say that it has vertical symmetry. So this one has two lines of symmetry. The next one, the Saints logo, only has one line of symmetry. That has vertical symmetry, but not horizontal symmetry. This next one's a regular pentagon, which means all those sides are the same, all the angles are the same. You can draw a line from each vertex across through the opposite side, and that splits that figure directly in half. You can see that this point would end up there after the flip, this would end up there, this whole line segment would end up here. Every point has a matching point on the opposite side. So that has one line going through that vertex, and it's going to have another line for each of these vertices. So that has 5 lines of symmetry. The last one, the butterfly, just has vertical symmetry straight down the middle. Every point has a matching point on the opposite side of that line. Alright, so I want you to try each of these, draw those lines of symmetry, and then describe how many lines of symmetry you're able to draw. And then at the bottom, you're going to say which ones have vertical symmetry and which ones have horizontal symmetry. We're going to do the same thing on the next page and then sort these letters into their type of symmetry or if they have both. All right, when we talk about rotational symmetry, it's really the same idea. The pre-image and image look the same. It's just that it's going to be after a rotation instead. So the symmetry is always going to be described by the angle of the rotation. So if we can rotate something 180 degrees and it looks the same, that's the type of rotational symmetry that it has. So we're looking for what angles we can rotate these figures by to have rotational symmetry. Well, there's Z. If this flips upside down, it's going to look exactly the same. So if we rotate it halfway around, or if we rotate it 180 degrees, that's going to look identical. So that's one of the angles by which it has rotational symmetry. The other one is actually going to be true for everything. If we rotate this 360 degrees, it's going to look exactly like it did before. So we're actually also going to include that in one of the angles of rotation. All right, the recycling symbol, if I imagine this arrow going to that spot with this arrow, it can also rotate again one more time to here, to this arrow, and then one more time to end up where it started. It's rotating around a third of the way each time. What's 360 altogether? A third of that would be 120, then 240, then 360. It's rotating 120 degrees each time, ending up with an identical picture. A regular pentagon here again. If I imagine this point rotating to there, then to there, then to there, then to there, then to there. It's taking 5 turns to get to a full 360 degrees. 360 divided by 5 is 72 degrees. So this is 72 degrees. Then these two together is 144. Then the next one added in gives us 216. 4 turns together would get us up to 288, and then that 5th turn makes it 360. So I'm going to say 72 degrees, 144, 216, 288, and 360. So that has 5 different rotations we can make to create the exact same image. The Saints logo cannot flip upside down. It actually can't rotate any way aside from all the way around. 360 is the only angle that we can rotate that at to get the exact same image. So then we have some important language that we have to talk about here. It's really just 2 words that, we kind of actually already talked about these, we just didn't name them. When we have a 180 degree rotation, that's called point symmetry. So if you can rotate something by 180 degrees and get the exact same image, that is called point symmetry. It's a type of rotational symmetry, just happens to be 180 degrees. So this one has point symmetry, this one does not, this one does not, this one does not. That's the only one with point symmetry because you can flip it upside down and it looks the same. I guess I shouldn't say flip. A flip is actually a reflection. You're turning it upside down. The only other word we have to be familiar with here is the order of rotational symmetry is the number of times the figure can be rotated within 360 degrees. So you're kind of just counting how many angles you wrote down. 1, 2, that has an order of 2. 1, 2, 3, that has an order of 3. 1, 2, 3, 4, 5. The order of that is 5. The order of this one is 1. So everything has an order of at least 1. Depending on how many angles it has in addition to that, that's the order. All right, so we're going to state the order of the rotational symmetry for each figure, a square. I can imagine each of those points rotating towards any other point. So I rotate once, twice, 3 times, and 4 times all the way around. That has an order of 4. There's 4 different rotations we can create there, either by 90, 180, 270, and 360, and that creates the exact same image. We can also say that this has point symmetry because you can rotate it by 180 degrees. I'm not going to draw this shape. A regular 40gon is just a shape that has all the same sides. That's what it means by regular. All the sides are the same. All the angles are also the same. And a 40gon just implies that there's 40 vertices. So instead of just having 4, like we do on a square, there's going to be 40 corners to this shape. It being a regular shape is really all I need. Any one of those vertices can move to any other vertice and create the same shape that has an order of 40. Now we have a rectangle down here. If I imagine this rectangle turning 90 degrees, it would end up taller than it is right now. So that's not identical. So that's not an angle of rotation. All we can really do is rotate it 180 degrees and then back to where we started. 180 gives it point symmetry, and it has an order of 2 because there's 2 different rotations we can make there. Last one is called a pentagram. We have a star inscribed inside of a pentagon. Any vertex can end up on any other vertex. It's still actually a regular shape. So that has 5 different turns that we can make to create the same image, giving us an order of 5. All right, try to state the order of each of these figures, and then decide which ones have point symmetry. All right, hope this helps. Good luck.